Welcome back to the Ephemeris podcast. It is your host, Ophélian, and I am very, very sorry for the last 2 weeks. I tried my best to get episodes out while I was organizing events and on holiday, but turns out that doesn't work out very well, especially when um, I don't even have time to figure out researching an episode. But, anyways, that is beyond the point. I know this podcast episode was supposed to come out on Sunday, but it's coming out on Monday, and it's because of how hectic the last 2 weeks have been in terms of actually getting a podcast episode written and published. But anyways, we're here. It's time to conclude geocentrism in antiquity once and for all. Because after this, we're going to move on to Aristarchus of Samos, and while he did come before a lot of the astronomers that we've already talked about, he's going to have a different train of thought that is going to build up after antiquity, because the person we're talking about today, he created geocentric kind of theories that stuck around for many centuries. And yeah, even though we've had some deviations with Philolaus and Hipparchus, I think those are just important kind of points in history to hit because they had more mathematic influence. But yeah, anyways, I know I haven't mentioned who is we're talking about in today's episode. It is Ptolemy himself, and we've talked about Ptolemy before. I think it was the Persian astronomers that we talked about, and we did a kind of like a surface level explanation of who he was and what he did, but today we're going to dig in further into kind of Ptolemaic astronomy, the Ptolemaic model, all of that good stuff. So yeah, Ptolemy was an Egyptian astronomer and mathematician, and he lived in Alexandria. And once again, I hate to say it, but we don't know that much about Ptolemy other than that. I know I have to say that time and time again on this podcast. It would be kind of interesting to go back into the past and see what these people actually were and how they looked like, because we actually don't know what Ptolemy looked like. So, yeah, it is what it is. We've discussed the Almagest, which was an influence on Persian astronomers, and I think that's pretty much what we're going to get into it, or what we're going to get into in today's episode, is what came out of the Almagest, which was kind of his collection of astronomical data and theories. What about that was so influential later on? Well, if we were to sum it up in a couple of words, which I was just going to do, but kind of didn't set it up as well as I thought I would, he was very integral to astronomy because he took Platonic theory, Hipparchus's mathematics, and put it together to be referenced by many astronomers to come, which I've already talked about. So enough with the yibber yabber. The Almagest, it was the original name for it was not Almagest, it was Syntaxis Mathematica, and basically what that means is just, I think, the mathematical collection. So the Almagest is really just a mathematical collection, and it consists of 13 books. So the first book is a recap of Aristotelian cosmology as well as introduction to spherical trigonometry. Shout out to the Euclideans, I guess. And also, if you do not know what I mean by Aristotelian cosmology, now is a great time to go back to the video that we did on Aristotle and refresh yourselves on it. So, yeah, that's book one. And then book two concerns observations of celestial objects. Book three discusses solar year and epicycles. And at this point, I do want to make it known that Hipparchus should be given lots of credit for the work he did in that area that might have made Ptolemy's book 3 possible. Book 4, lunar cycles, that's also another part where we got to give Hipparchus some credit, because he was before Ptolemy, and he did all that great work that we discussed in the last episode. Book 6 is about eclipses, and book 7 and 8 are about the precession of the equinoxes, which, again, Hipparchus's work seems to be like showing up again, which is interesting. It's a little bit weird how much credit can be given to Hipparchus for kind of starting or building the foundations for what Ptolemy talked about in his books. And as I was researching this, I realized that it was actually a point of controversy. Like, how much of the Almagest is actually his? Did he just kind of pretty much take pages out of Hipparchus's book, and was his work manipulated? Now, that part we'll get into once we're done with the newer parts of the Almagest, which we do not already know. So, yeah, hold on to that thought. So, all of the 8 books that I've referenced previously is kind of stuff that we've already talked about in a couple of episodes beforehand. And where it gets interesting, I think, is kind of the rest of the books, 9 through 13. And they deal with planetary motion, retrograde motion, and that's a great place to start talking about some of the new parts of the Almagest. So, part of the Ptolemaic system was the fact that the sun, moon, planets, and stars were attached to crystalline spheres, and they were centered on Earth, and they kind of turned to create the cycles of day and night, and like the lunar month, and so on. So basically, just the cyclical nature of celestial objects, Ptolemy believed, was due to some crystalline spheres around celestial objects. And it's interesting. I don't know, crystalline spheres, I mean, obviously we use a lot of modern physical concepts to justify that kind of stuff, but during that time, and really before it, there was nobody who concretely tried to justify day and night. Like, I was like, okay, crystalline spheres is a pretty funny way to justify that. What other ways have kind of historical figures tried to justify day and night? And I couldn't find anything. Like, actually. Most of it was either like people left it up to mythology, or it was just a natural part of an astronomical model. Like with Aristotle, I know we talked about that one excerpt where it's like, God lit a fire on the second celestial objects revolving around the Earth, and then there was day and night. So, yeah, it's interesting that there was a distinct way that Ptolemy tried to justify day and night. And next, Ptolemy put together epicycles and eccentricity to justify the irregular motions of celestial objects, or retrograde, because one used to observe celestial objects back then. I think we talked about this a little bit with Hipparchus. It's the fact that, like, let's say, for example, the moon doesn't just, like, go across the sky. Sometimes it'll kind of double back and then go, like, forward across the sky. So basically what Ptolemy said was, oh, that's because, you know, if you put epicycles and eccentricity together, you can justify retrograde motion. And if you don't know what I'm talking about when I reference epicycles and eccentricity, the previous episode is a great place to review that. Again, I'm not trying to plug the rest of the episodes in season 2, but it does have a lot of important information that we're talking about right now. So, yeah, we obviously know Hipparchus was responsible for the mathematical proof for the equivalence of both epicycle and eccentricity, but Ptolemy kind of threw that into his theory, I guess. So maybe you can give him a little bit of credit for doing something different. And kind of a nice excerpt that I found while I was researching that talks about retrograde motion in very good detail is this following excerpt. In the Ptolemaic system, each planet revolves uniformly along a circular path, the center of which revolves around Earth along a larger circular path, which is the deferent. Because one half of an epicycle runs counter to the general motion of the deferent path, the combined motion will sometimes appear to slow down or even reverse direction, which is known as retrograde. By carefully coordinating these two cycles, the epicyclic model explained the observed phenomenon of planets retrograding when at perigee. Perigee is not as important, but basically that's just a really nice excerpt that says there are kind of two forms of orbit happening, which is an epicycle, and then when one part of the epicycle is off of the regular forward path, it creates retrograde. So yeah, hopefully that doesn't really bother your brain cells too much. But additionally, Ptolemy created a really complex visualization to imagine this retrograde motion, if it's already not confusing in and of itself. So basically what he said is, let's take the Earth and place two spherical shells around it. They're not connected. There's a little bit of space between these shells. And now let's take, suppose, the moon. Put it within a sphere and place it in the space between these shells around the Earth. So it perfectly fits right between that space, and then set it into motion around the Earth, but always between the two shells, right? So it's just squeezed between the two spherical shells around Earth, but there's also kind of a sphere around the moon. So if you think about that practically and in modern terms, or at least the way I would explain it, setting this supposed moon sphere, or sphere surrounding the moon, into motion in between the shells requires a rotational force on the moon sphere, which would make it spin off-center, so this model would it would almost represent retrograde motion. That's how I think about it. To me, that makes sense. Maybe it doesn't make sense to you. But what I do hope is that in one way or another, you do get what retrograde motion means. So, yeah, another thing that Ptolemy discussed was his reasoning for the Earth being at the center of the universe. And I know we've heard a lot of justifications in the past with, I think it was it Aristotle? I think it was Aristotle as well. So he stated that if the Earth moved at all within the universe, objects on Earth will not land in their intended position. Like, for example, if you throw an apple directly up as the Earth is moving across the universe, it would not land directly beneath you. It would probably land behind you or in front of you, depending on the direction of the Earth in the universe. And therefore, the Earth cannot be moving in the universe and is stationary. But then again, things at the center of the universe do not move. So the Earth must be at the center of the universe. And obviously, you see the flaw with the reasoning. Thanks to Isaac Newton, we can happily laugh at the flaws in his theory. But he said what he said. It was a long time ago, and we know what's right now. So regarding axial rotation as well, so the next thing, Ptolemy said that for Earth to have an axial rotation, right, it would have to spin noticeably fast. But obviously we don't feel the Earth rotating on its axis, even though it does it really, really fast, right? It takes a day for the Earth to complete one axial rotation. But yeah, obviously that's another kind of flawed explanation for axial rotation, because we are such small objects in this universe, and we are not to feel the motion of the Earth. So, yeah. The last miscellaneous principle, which I think is interesting and is contained in the Almagest, is the idea that there is no such thing as up or down in the universe. And, yeah, I think that's still kind of a concept that we talk about in modern physics today. Like, in the universe, what is up? What is down? There's no such thing. So I guess that's something that he got right, even though you can laugh at all of the, denying axial rotation and saying that the Earth is at the center of the universe. So yeah, that's all for the juices of the Almagest. But we talked about Ptolemy being controversial. And we really haven't gotten into kind of why. Why was it so controversial? Okay, well, there are a couple of things that came from Hipparchus. He could have been influenced. That's fair, but other than that, there's not much, right? Well, because his observations of celestial objects were too convenient for his theories and turned out to be way off from the true positions. Later astronomers, who discovered a lot of his stuff was false, like Newton, kind of ridiculed him um, for how he fabricated his observations of celestial objects. So, yeah, that's one reason why he was controversial, and for that reason, Newton even considered him a fraud, which is a pretty strong word. But there's also another perspective that is taken on the fact that his observations of celestial objects were too convenient for his theories. It's kind of like more of, well, Ptolemy probably cherry picked his observation, and he's not necessarily a fraud for it. Like, there could easily have been like Middle Age astronomers that took so many observations and recorded so much data and decided, oh well, this probably fits in with what is currently accepted. So I mean, he's not so much of a fraud for it. And there's also a lot of doubt that's put in on kind of the numbers that Ptolemy calculated that are in his star catalogs in his collection. And I think it was like people suspected that he just like took Hipparchus's numbers and meddled with it a little and then just made it his own. So yeah, it really is up for debate, like whether Ptolemy was a fraud, whether he just cherry picked his data, or he kind of unknowingly had some incorrect observations. And yeah, that's pretty much all there is for Ptolemy. I mean, he really just summed up geocentrism as a whole in his Almagest, and there were a lot of ideas that stuck around for a while. So yeah, that's all I have for today's episode. If you guys enjoyed hearing about Ptolemy, make sure to subscribe if you're listening on YouTube, and leave me a follow if you're listening on Spotify. Until the next episode where we talk about Aristarchus, I'm very sure of it that we will. I will see you guys later. Peace.